So for your next example from section 6.4, let's look at problem number 12. Problem number 12, I'll need you to read that in your book, but if you have your book opened, here's what it says. It says that according to the website www.torchmate.com, manhole covers must be a minimum of 22 inches in diameter, but can be as much as 60 inches in diameter. Assume that a manhole is constructed to have a circular opening with a diameter of 22 inches. Men have shoulder breadths that are normally distributed with the mean of 18.2 and a standard deviation of 1.0. So men have shoulder breadths that are normally distributed, so it'd tell us that. And they have a mean equaling 18.2 and a standard deviation equaling 1.0 inches. Both of those are in inches. So I'll just put it here with the last one. And they want to know what percentage of men will fit into a manhole if a manhole has an opening with a diameter of 22 inches. So we have a manhole and it has an opening that has a diameter of 22 inches, and they want to know how many men can fit in that manhole. Okay, well, we could do that. When they ask for what percentage of men can fit, there's not a group going on, so everything's the same as it was. And so the first question in number 12 is really a 6.2 question. Here we know the average is 18.2 in terms of shoulder breadth, and you're going to fit provided your shoulder breadth is less than 22, or a man's shoulder breadth is less than 22. Well, no problem. We need to just look that up. And the way we look it up is by finding the z-score. And so we just go through the motions of finding the z-score by taking 22 and subtracting away 18.2 to come up with 3.8. And 3.8 is a really big number, right? And so we looked that up, and it's in the 3.5 and higher category, and therefore what we're going to have for that one is 0.9999 as we look that guy up. That means the percentage of men that can fit down that manhole is 99.99%, and that would be reflected in the answer there. There is a second question associated with number 12. It's part B, and it says that there's a company employs 36 men who work in manholes. The 36 men are randomly selected. What is the probability that their mean shoulder breadth is less than 18.5? Does this result suggest money can be saved by making the manhole smaller than a diameter of 18.5? So it's a little bit different of a question. The question is, what's the probability that the 36 men have a mean shoulder breadth less than 18.5? So what's the probability that 36 men have a mean shoulder breadth less than 18.5? And so what does that look like? Here we go. We got a normal distribution, and the mean's not going to change even though we have 36. It's still going to be 18.2. They're still considering 18.5, and we want them to have a shoulder breadth less than that. And so an average shoulder breadth less than that. But one thing that we know is our mean for a group is going to stay the same, but the standard deviation for the group is no longer going to be 1. It's going to be 1 divided by the square root of 36. And so if we look at 1 divided by the square root of 36, we're going to get 0.17. We'll use that to go into our formula. So we need to find the z-score of 18.5 by subtracting away the mean of 18.2 and dividing by our new standard deviation, 0.17. As we look at what that is, as we look at 18.5 minus 18.2 and divide by 0.17, we get the z-score of 1.76. That's what we got to look up, and as soon as we look that up, we'll have our answer. So as we go to the the z-score chart and look up 1.76, we'll find that that corresponds to a value 8608. 1.76 is 8608. That's going to be the answer to our question for this second part of 12. That these 36 men are going to have a mean shoulder breadth of 0.8608.